Hello, everybody. And just to wrap up the first day of JetBrains .NET Day, we're going to talk about migrating from SQL to NoSQL with .NET and Dapper. So this is a video that was making the rounds a while back on Twitter, and it's just the guy on the right is putting all the blocks into the same hole, no matter what shape they are, which clearly caused this person on the left distress. So sometimes I feel like relational SQL databases are the hole that we put every block into, but I want to try and take that in the other direction. Can we try to use a NoSQL database as if it were a relational database? And so that's my hypothesis, and I think the answer is mostly yes at this point. And that's what I'm going to be doing with a utility that I wrote called SQL Server to Couchbase. And it's a set of tools that, for now, can help you copy the structure and data of a SQL Server database into a non-relational NoSQL document database, specifically Couchbase. And I'm looking at Couchbase because obviously I work there and I know the product very well, but I also think it's the most relational friendly NoSQL database out there, if that makes any sense. So hopefully you'll see what I mean as we go forward there. Just a reminder, I know you're all watching me live, but in case you're watching this recording somewhere else, thank you very much, JetBrains, for having me to .NET Days 2021. If you're watching this elsewhere, definitely check out the next JetBrains event, next JetBrains .NET Days. And also just check out the wonderful JetBrains tools. My favorites are ReSharper and DataGrip. I'm going to show you some DataGrip today, actually. I think it's a fantastic tool that since it came out, I've been using it pretty much almost every day. So I'm very happy with that DataGrip, and we'll see some of that happening today. My name is Matt Groves. My title is now involved the word marketing. So I used to be titles like software developer and developer advocate. Now I'm a product marketing manager. So that means I get to work on a lot of that marketing baloney that developers get annoyed by. But I'm trying my best to make it less annoying and more valuable and more technical focused as much as I can. And this cartoon is what I looked like pre-2020, when I used to go outside and I put on a tie every once in a while. And towards the end of the presentation, you're going to see a cartoon that better represents the state that I'm in now. So look forward to that. You can reach me on Twitter, on LinkedIn, all those other things, MVP and Pluralsight and blah, blah, blah. Okay, let's get to it. We're going to migrate from SQL to NoSQL. So the tool that I'm working on is kind of like a automatic language translation tool. So if you're familiar with Babelfish or Google Translate, it's kind of in that vein. These are really useful tools to help understand someone, to help learn a language, but it doesn't replace actually learning the language, at least not yet. So things like idioms aren't translated well. On the left here, you see a literal translation. I'm not even sure what the original language is, but the English version doesn't make any sense at all. I'm sure there's some idioms going on here or some sort of context that's absent. And if you're familiar with Star Trek: The Next Generation, there's a great episode called Darmok, and that represents the same sort of concept here. Like, you can do a literal translation of something and completely miss out on all the cultural context around it. So if you've not seen this episode, that is just proving my point even more. So definitely check it out, Darmok Enchilada Tanagra. I'm sure you've heard of that before. But what I'm going to do is try my best to make the Google Translate for databases from SQL to NoSQL. And since I've been using SQL Server a lot of my career and Couchbase a lot of my career, I feel like I'm in a pretty good position to understand some of the context around both and make an attempt at as much as possible an automatic translation. So let's start with my really basic SQL to Couchbase dictionary. So think of this as kind of like a phrase book or like a Spanish to English dictionary sort of thing. We've got the SQL relational concepts in the first column and the Couchbase concepts that match in the second column. And then kind of some notes on what you're gaining or losing in the translation there. Since it's not a perfect translation, because they're not both the same kind of database. So this is SQL Server specific, but I can certainly see MySQL, Oracle, Postgres having a very similar mapping. So the first row there, by moving from a SQL Server to a Couchbase cluster, the sort of the main thing we're gaining there is all the benefits of NoSQL that you've probably seen or heard before. Scalability, able to add more machines to a cluster instead of just traditionally a single machine. You can add machines to a cluster, which also gives you replication and high availability options. And the other thing that Couchbase has specifically is a built-in caching. So it's kind of like, you normally have to pair SQL Server with a tool like Memcache or something. With Couchbase, it's built right in. So just from that, we're gaining all those things. And that's kind of one of the main reasons that people go to NoSQL in the first place. The next row down, in SQL Server, they have things called catalogs. Usually people refer to these as databases, though. And in Couchbase, a similar concept called a bucket. And I know that's an overloaded term because Amazon also has something called a bucket, but this is a different bucket, Couchbase bucket. And then the next level down, we have a schema inside SQL Server. Now, when you're using SQL Server, you might not even be aware of schemas because you may be using DBO as the default all the time. Or maybe you are using schemas for things like microservices or multi-tenancy. If you want to set part of the data to be organized in a certain group that's only accessed by certain applications or certain people, that's what a schema is for. But sometimes you see DBO, and that just represents the default schema. The next thing we do is go down to table at SQL Server level, and that roughly translates to a collection in Couchbase. The difference there is that for create a table, you have to define, okay, here's the columns, the column names, the data types, all those things. You have to define those up front. With a NoSQL Couchbase collection, it's really just you give it a name, and this is a place you can put documents. You don't have to define anything about them. The data types, the schemas, anything like that. You just have a collection, and it contains documents. Now, typically, they're going to follow a very similar model, very similar set of values, but they don't have to. So that's kind of something you're losing there, depending on how you look at it. The next one is a row. So each table has one or more rows. Well, 0 or more rows, technically. And in Couchbase, this similar concept is documents. So a collection has 0 or more documents. A table has 0 or more rows. The difference is with a NoSQL document database, the data format is JSON. So it's a flexible format. You can put whatever JSON you want in there. As long as it's valid JSON, it can go in there, and that's fine. So it can vary from document to document. Hopefully not a lot of variance, just when you need it. But that gives it more flexibility there. So that's something you're gaining. So you can see kind of a trade-off here between big upfront design and limitations and constraints versus flexibility and you have to have a little more discipline about your data. Next thing down in SQL Server, the language you use to interact with it is called Transact SQL or T-SQL. In Couchbase, there is a SQL implementation. This is kind of what we were talking about before slides, is that Couchbase has a full SQL implementation. And you'll see a little bit of that today, but when I say full implementation, I mean everything you'd expect from SQL is there. So joins, insert, update, delete, merge, common table expressions, subqueries, aggregations, all that kind of stuff. It's all there. So this really sets it apart from other NoSQL databases in that you have all these capabilities. So it's a lot more comfortable as a relational developer to make the transition. And as we were saying before, just drop that into DataGrip and run the query, and it might run as is. Maybe some small tweaks. We'll see that later. In SQL Server tables, you can define a primary key. In Couchbase documents and other NoSQL databases, each document has a unique key, and that's per collection. So some difference in translation here. It's roughly the same thing for the most part, but with a NoSQL database, you can't really have a true compound key, right? It's just one key per document. Now you could work around that and use a delimiter in your key. Some of our customers and users do that, so you have basically one key that you break into two parts if you want to. The other thing is in SQL Server, you actually don't have to define a primary key on a table. And I think there are very few situations where you'd want to do this, but it's an option as well. And you can't really do that in Couchbase. Again, the workaround would be just put some GUID in there, something meaningless that you're not going to use. And the last thing is index. So depending on your experience with SQL Server, you may not write indexes, you may barely write indexes, or you may write indexes all the time. And the same is true for Couchbase. In order to support SQL queries, you need indexes on the data. So that's kind of the translation card there. And that's the premise I'm going to start with my idea of a conversion app. So let's dig into some more detail. But first, I want to talk about the word migration here. I don't want you to be put off by this word. It kind of implies that we're dropping relational, we're dropping SQL completely and abandoning it for NoSQL. And I'm sure that everyone in my marketing team, wants that to happen. But the reality is always messier, right? So instead of saying abandon SQL and migrate to NoSQL, I consider this effort more of a bridge between the two, between relational and NoSQL, a bridge that you can either use them together, or you can make an easier transition from one to the other, or vice versa. So there are many use cases where you'd want SQL to hang around and NoSQL database to work with it. So I'm going to go through each step of the application that I wrote, the tool that I wrote, and show you, what's going on and the code for it, how I'm using Dapper in the process. And I'm going to also point out what can't or maybe shouldn't be automated along the way. We're going to automate as much as possible. But if you do try to automate too much, you're going to end up with Marvin here, the paranoid android, very depressed. You're trying to automate things that really need a human to look at them first. All right, so step 0, first thing we do is we've got to connect to our databases. We'll mostly be reading from SQL Server. We're going to be looking at it. We're going to be reflecting on it. What tables are there? What indexes are there? What users are there? Turn this light on here a little bit. I'll mainly be writing to Couchbase, so creating those things, the buckets and scopes and collections and keys, indexes, documents, users, all that stuff. Now, throughout this demonstration here, I'm going to be using a data set called AdventureWorks. It's a SQL Server, a Microsoft official sample data set. I think it's a really good example for demonstrating SQL Server capabilities as well as a realistic translation effort to a NoSQL database. Okay, so first snippet of code here. We're going to start with a SQL connection, and that's going to be used by Dapper. So I'm not going to go into the basics of Dapper here. There's lots of other presentations and material on Intro to Dapper, but it's basically a tool that you're going to use to interact with relational databases, in my case, SQL Server. But it's just a set of extension methods. So as long as I have an object that implements IDB connection, I can run Dapper extensions on that. So SQL connection here is an object that implements IDB connection. So that'll be my entry point to using Dapper. Second thing is I'm going to connect to a Couchbase and get a cluster object. So now my .NET client will have all the information it needs to communicate to every machine in the Couchbase cluster, just for this cluster object. So as a developer, you don't have to worry about, there's 10 machines out there or 5 machines or 100 machines. It doesn't matter because you're going to interact with it through this cluster object and let the client and Couchbase handle all the rest of that routing business. I've also, throughout this presentation, there's a whole bunch of logger code and some other things that I've removed just to make it easier to fit on a slide and easier to read. But for this type of utility, you've got to make sure to put plenty of logging in there in case things go wrong, so you know where they've gone wrong in the process and how you can deal with them. So the third thing I've got here is this serializer setting. So I'm not using this the default serializer. I'm actually adding some custom SQL Server types, and we'll talk about those in a bit. But that's an important thing to deal with if you want to handle as much of the data as possible. Okay, step 1 then, once we've connected the databases, we're going to create a Couchbase bucket with the same name as the SQL Server catalog. So on the left here, I've got the AdventureWorks catalog here. And on the right here, I've got the AdventureWorks 2016 catalog. Now, actually, they're different names here, right? Because this is a situation where do I really want to create my buckets automatically? Because there's lots of things that need to go into the process of creating a bucket and thinking about it. So in Couchbase, how much RAM do I want to give it, for instance? How much replication do I want this bucket to have? And things like that. So these are things that can be configured. So if I'm going to configure those anyway, I may as well just make the name configurable as well. So in this case, I've got 2 different names, but normally they would match. That'd be fine. This is all easy to set up in Couchbase, but it needs some human thought behind them. So the actual flipping switches is just a web form and some drop downs and things like that. But you need to think about how much RAM do I actually need to give this cluster. Is it a development cluster? Then maybe just the minimum. But if it's production, then I need to think about how much RAM do I have per box, things like that. We're not going to get into that too much today. The code for this is, again, none of this is using Dapper yet. We'll get there. But the first thing I'm doing is these are the settings I need to configure a bucket. So as I mentioned, the RAM quota, the name of the bucket, what type of bucket it is, things like that. I'm just pulling that right from config. Got a question in the chat here. What would be the benefits of moving from relational database to a non-relational one? So yeah, I kind of touched on that early on. The idea of being able to more easily scale, handle high availability use cases, and also in the case of Couchbase, maybe some performance gains. We'll talk about that a little bit later as well, because there's a built-in cache there as well, and also flexibility. So if you're in a use case where data flexibility is important, and you don't, your data doesn't fit neatly into a relational table all the time, those are all situations where you might want to look into a document database like Couchbase. Okay, the second thing is I'm going to actually create the bucket in Couchbase. It's only going to create it if necessary. So I've already created it manually. This is just going to be a no-op essentially. And the third thing is I want to wait until the bucket is ready and the services on it that I want to use are ready. And there's lots of services you can use in Couchbase. The ones I care about are key value and query. So key value is just looking up documents by their key, and query is SQL queries. So we want to have those both available. I'm going to use both for this translation app. Last thing is we're going to get what's called a collection manager, and this will allow us to create scopes and collections in Couchbase as the rest of the program goes on. All of this code is on GitHub, by the way. It's got more logging statements in it, but it's all on GitHub, so you can go. I'll give you the link later on. You can go check it out and try it out yourself. Next thing to do is create scopes and collections, and this is where it actually starts getting a little interesting. So on the left here, we've got a AdventureWorks database, a little screenshot from SQL Server Management Studio. And on the right is a screenshot from the Couchbase admin console. So if SQL Server makes use of these non-DBO schemas, as AdventureWorks does, then we're going to create corresponding scopes in Couchbase. So we've got human resources, person, sales, production, etc. We'll create those scopes over in Couchbase. And then for each table in those schemas, we'll create a collection inside the Couchbase scope. So over here, we've got person, schema, address, table. That's how it looks in SQL Server. It's schema.table. And over here on Couchbase, we've got the person scope and the address collection. So we're just kind of translating those literally over there. Now, there's some manual considerations here, things like access levels. Do I want to translate all these schemas into their own scopes? Maybe for certain applications, only access the person schema or the person scope, for instance, like microservices. Or maybe you're using schemas for multi-tenancy. So you have tenant1.address, tenant2.address, and so on. So you think about that. If you don't really need a separate schema, if it's just there for organizational reasons or whatever, then we can collapse them all into one single collection name. So it's an option that's out there. One other thing, which is pretty cool, I'm going to show a screenshot here from JetBrains Data Grip, is, and actually just kind of discovered this today, is that if you connect to a SQL Server database, it's actually going to organize the schemas and tables in a hierarchical fashion. So unlike SQL Server here, where it kind of mashes them together, Data Grip shows them as a hierarchy, as I would expect them to be shown. So I can expand person and just look at the person tables and so on. So that's a very cool feature I like of Data Grip. One other thing to point out here in manual considerations, did you know that SQL Server allows really, really long table names and schema names, and Couchbase has shorter limits than that? Guess how I know? Guess how I found out? So we have to think about that as well. And if you're using some more of the advanced or obscure features of SQL Server, like temporal tables or calculated values, a direct translation here becomes more challenging. So that's some programmability we have to that's not inherent to JSON data. So we have to figure out another way around that. So again, to manual considerations. It's not impossible, but it's just going to require some extra non-automated work to do that. Yep, so there's person and an address, and then person address on the right. All right, so here's the code. We're finally going to get into Dapper here. And this is why I chose Dapper, because it's really so easy to just drop in a SQL query and start getting results from it. So right here, I've got a SQL query that's going to query SQL Server for all the table names and schema names. And I'm querying from information schema.tables. So if you've not heard of that before, that's basically how you get metadata about stuff that's in SQL Server, about objects in SQL Server. So I'm just give me a list of all the schemas and all the tables that go in them. Then I'm going to construct the collection name and scope name as strings. So this is going to go off the decisions we made about multi-tenancy and microservices. Either combine them into one name, and if they're really long names, like I mentioned earlier, it's actually going to substitute a shorter name if necessary, and it'll do this consistently. That's why I've put these in their own methods. Then we'll create the scope if we need to. We should only have to do that one time, and create the collection if we need to. And the reason I've put these if statements on here is because this is a program that's meant to be able to run multiple times. It's meant to be interruptible. So if something fails or something's stuck, we can quit, or it'll end, and then we can run it again and not have to do the same kind of work all the way from the beginning. So I've tried to code that in here as much as I can. All right, the next step is, once we've got the scopes and collections in place, we're going to actually start copying data. So if I have a row of data here in the address table, I need to create a JSON document shown here in the address collection. So this looks kind of messy. This is kind of a crammed together JSON view here. So let's zoom in on that document a bit, get a prettier view of it. So this is the translation. I read the data from a SQL query in Dapper. I serialize it to JSON in Couchbase. This is the document key. So this is kind of like the primary key in SQL Server. It's not exactly the same thing, but it's kind of the equivalent there. Notice that the key is also inside the document as address ID. Now, this duplication is not necessary and may be harmful if you think about it in the long run, but it does make translating the SQL very much easier later. So some trade-offs there again. This might be something I introduce as an option in the program. Like, do you want to put it in the document, or do you want to omit it from the document and just leave it as the key? The other thing is, SQL Server has these proprietary data types. So one of them is called geography. You have a geography type that contains a location on the map. And so if you look at that in SQL Server, it's just a bunch of binary, not human readable. So I've imported the Microsoft SQL Server types library, and that will allow me to serialize them to JSON. So you can see here it's got the lat and long, z, all those values you'd expect from geography. This is an area that might need some improvement in the future. There's a lot of data types in SQL Server, proprietary ones, things like the hierarchy data type that might be tricky. Other lesser used types, custom data types could be an issue. So you need to think about that. And copying the data actually could take some time as well. But there's something I've learned about Dapper that I think speed things up for a bulk copy like this. So we'll look at that in a second here. So here's the code to copy the data over. This is the first step. We're going to again use Dapper here to get a list of all the tables. And I want to exclude the temporal tables, the history tables, because typically those are massive and there's no primary key. So we have to put some human thought into those. If you're not using temporal table types, then don't worry about it. There are some very interesting use cases for temporal types, but I'm not going to make an attempt to automatically convert those over. So once we have those table names, we're going to go ahead and start copying the data. Now notice here I have this sample data parameter here. That's in case I want to show this program in action, but I don't want to actually copy 1 million records over, let's say. So I'll be using this later on in the live demo. And also notice pipelines here. I've taken a lot of the pipeline stuff out of this code because I'm not going to cover it today, but the library that I've written allows for some advanced filtering and transformation. So if I wanted to, for instance, just copy data over that's less than a year old, or copy data over but obfuscate the PII, for instance. Those are some things you'd use pipelines for. So now I'm going to drill into this next copy data method here. Show the details of this. I've omitted again a lot of logging here and filtering, transforming stuff. So I want to point out this line here. I'm actually opening a second connection to SQL Server with Dapper, and I'm setting, if you notice there, buffered to false. It's true by default. So from the Dapper docs, I'll just read this to you here. A non-buffered query is equivalent as streaming. You only load objects on demand. That can be useful for a very large query to reduce memory usage, which is exactly what I want to do here. I'm doing a select star on every table, basically. So, copying those all into memory or buffering those into memory could really increase the memory footprint of this program and really slow things down or possibly even cause overflows and crashes and things. So that's why I have buffered false here, and actually ends up, I think, speeding up the process as well. But I can't use the same connection for that. I'll get an error about connection already being in use. So that's why I've opened a second connection here. Now, each row then returns a C# dynamic, an object of type C# dynamic. So I'm using dynamic because otherwise I'd have to create a class for each table. And at that point, it kind of defeats the purpose of automating this. I'll have to create potentially 100, 200 classes or whatever. I guess you could use some code generation to do that if you really wanted to. And the next thing is I'm going to use Dapper to interrogate the table and figure out which columns make up the primary key. So remember, in SQL Server, you can have multiple fields making up the primary key in a table. So I need to figure that out so I can join them all together into one document key for Couchbase. And the last thing, the only line of code here that's really related to modifying data in Couchbase is this line right here. This will put that row of data as a dynamic object, and it's going to serialize it to JSON in the process. I'm using upsert here, which will either do an update or insert, depending on if the object exists or not. Because again, I want to be able to run this multiple times. So I don't want this to fail if the item is already there. Okay. What about migrating to Azure Cosmos DB is the question coming in there. Yeah, I would be open to someone contributing a PR for this project to do that. Right now, it's just kind of an experimental, like pre-alpha effort to convert things over. We'll get to some things in a second here that might make you think twice about taking this approach with Cosmos, though, because there are some things that Cosmos is lacking in terms of fitting a relational model. Okay, next thing is we're going to copy indexes. So all these steps, by the way, are optional. You could choose to skip the indexing step if you want to. But what we need to do here is for each SQL Server index, we're going to create a corresponding Couchbase index. So with SQL Server, indexes can be created with the create index syntax. So I'll just pick one here, the index on the address table for the state province ID field. And the create index syntax looks like that on the bottom right. And that's how you create an index in SQL Server. So since I know that, I can then create a similar index for Couchbase. So this one on the top left here, that's how you create an index in Couchbase. Or no, sorry, the bottom right here. That's how you create an index in Couchbase. So you can see the syntax is very, very similar there. Create index, index name on bucket, scope, collection, and then the fields you want to index. And so I go through and I create those indexes. I calculate them automatically based on the metadata I can pull from SQL Server. Some manual considerations here. So, depending on your experience with SQL Server, my experience has been that SQL Server databases are criminally under-indexed. There's not enough indexes there. There's not the appropriate amount of indexes. So when you move over to a NoSQL database, you may need to add more indexes than you thought you needed because your existing data was not indexed properly. Or the opposite side of the fence, with AdventureWorks, there's a ton of indexes in there. There's hundreds of indexes. And we don't necessarily need all of those when we move over to non-relational data. So fortunately, Couchbase has some tools to tell you, hey, these are the indexes that are being used. These are the ones that are not being used. And also, it has some tools to recommend indexes that might speed up your query as well. So those are things you kind of have to do manually, though. Also, with NoSQL databases, typically there aren't unique indexes available. So again, there's some workarounds for that in maybe with key construction or with eventing services, things like that, that you could replace those. So these are really indexes that are purely there for performance reasons and not necessarily for business logic or data constraint reasons. Okay, this is probably the biggest method in the whole shebang, is the create indexes method. I've removed a lot of this here to fit on one slide because this is a huge query right here that gets all the indexes, their names, and the fields that they index. And I've cut out about 90% of it, but you can check it out on GitHub, especially if you have ideas to improve it, to make this more readable or more accurate. I would love that sort of commentary. But that's a big old query there. Again, running in Dapper to get I just want the index name and the column names and the schema name and table name. That's the stuff that I need. Second thing is I'm going to do some string manipulation to get those fields, to use the correct escape characters. So in SQL Server, the escape characters are square brackets. In Couchbase, they are backtick. I think that's very similar to what Oracle does as well. So I have to, especially if you have field names that have spaces in them or dashes in them, you have to use the correct escape characters. And the last step here is to go ahead and execute a create index statement on Couchbase. There's actually a lot of room for improvement here in terms of deferring indexes and running them all together to make them more efficient. So there's some work to be done there. So right now, indexes are kind of a slow spot in this utility, in creating them for the first time, that is. Okay, and the last thing is we're going to I think the last automated thing I want to talk about today is copying users over. So for each SQL Server user, I want to create a Couchbase user. And for each SQL Server permission that user has, give an equivalent Couchbase permission. Now, AdventureWorks doesn't come with any interesting users, sadly. So I invented one. This user has permission to only 3 tables. So we've got very fine-grained permission here. 3 tables. It has select, insert, and update permission, except for 1 table, which has delete permission as well. So very, very fine-grained permission. I don't know if this is a common scenario of doing this fine-grained permission or not, but I wanted to demonstrate that it's possible in SQL Server and in Couchbase. It's kind of hard to read. I'm happy to show this when we get to the demo. In Couchbase, I do my best to map over the permissions, but the thing with Couchbase is it actually has multiple APIs to work with data. So it's not just SQL on Couchbase. You can also use the key value API. I'm not going to show the code for this because it's a bunch of switch case statements, but this is a reason why creating users should really only do this for convenience purposes. If you have a ton of users that have a lot of fine-grained permissions, this will give you a pretty good head start. Otherwise, I would stick to a manual approach here because you don't want permissions to leak through that you don't want the users to have, right? So, and not all users make sense to copy over, right? Do I really need a DBO user on my NoSQL cluster? And then things like LDAP Active Directory, that's integration step that's separate from this utility. Okay, step 6 is we need to convert the application over from using SQL Server to using Couchbase. Now, I haven't actually written anything that can do this, sadly. It's not impossible, but I'm reminded of this XKCD comic. I do have some good news on this, but I just want to reference again that when we're migrating data, we may not actually be abandoning SQL Server. So if we're not abandoning SQL Server, we're not necessarily abandoning the app that uses SQL Server either. We may want that to stick around for a short period of time or maybe indefinitely, depending on what we're doing. But I just wanted to make that clear that this migrate doesn't necessarily mean abandon. We're building a bridge to make a migration forward, there and back possible. Okay, so we talked about this early on. We can look at a SQL query in SQL Server, a T-SQL query, and switch that to use Couchbase. So I pulled this query from Microsoft documentation. This is a AdventureWorks sample query, and it returns the first and last names of all employees and the cities in which they live. This is the data that it returns. So we've got Saeed and Kim and Hazim, the first 3 there for Bothell, Carnation, Kenmore. Actually looks like Camation because of the kerning there, but that's Carnation and Kenmore. All right, so that's the data that's being returned. Here's the same query converted for use with Couchbase. Couchbase using the Nickel query language instead of Transact SQL. So I'd be curious if anyone can spot the difference here. So if you can spot the difference, go ahead and throw it in the chat. I don't know. I can give you some bonus points, I guess. I don't know. You can use them on anything, but be curious to see if you can spot the difference between those 2 queries. So some manual considerations here while you're typing in your guesses. That these queries are close, right? But they can't really be migrated automatically. Again, we're back to the XKCD comic of translating one language to another. But the syntax is very, very close. And so if you're used to running queries like this or complex queries like this, you can take that same approach with the data in Couchbase. And hey, Cyber Undead got the answer. Yes, that's correct. It is the concatenate operator. That is the only difference. And oh, Roberto got it as well. Good job. Bonus points to both of you. So Couchbase uses the Oracle style concatenate operator, and SQL Server uses a plus. Otherwise, these are identical queries, which is really cool. And this goes back to the Cosmos question as well, is that notice there's a couple inner joins here. As of today, there is nothing like an inner join in Cosmos DB. So what, you can't really do this same kind of relational style query with Cosmos. There is SQL, but there's no inner join. There's lots of stuff that's missing from the Cosmos SQL implementation. So what you typically do with Cosmos is then go ahead and consolidate your data, which we'll talk about in a second here. So you can work around not having joins. But with my approach, it's like we're just going to do a lift and shift of the data. We're taking our relational data, putting it on a NoSQL database, and then starting there. And maybe we can optimize it later. Now, some queries will run, oh, by the way, here's the results. Same exact data. So Saeed, Kim, and Hazim, Bothell, Carnation, Kenmore, much better kerning this font. Same exact data. So some queries may run almost as is, just like this, but that's not always going to be the case if we're realistic. The syntax is very close, and if you're used to writing SQL, you're going to be very comfortable here. This is one of the things I really loved about Couchbase, is that I can take all the SQL knowledge of one of the most popular languages in the world is SQL, and apply that to a NoSQL database and get all the same benefits from NoSQL with the benefits of relational. Now, indexes, I mentioned this before, indexes here for this query, they can be reviewed. So is this query going to run? We can check that. Is this running the most efficiently we can run it? Or is there going to be some better indexing we can use for this? I've also noticed that like address ID is being used for a join here. We might want to change that to join on the actual document keys in the long run. But again, if we're just talking about doing like a proof of concept, lift and shift, let's just try to see if it works, then this is a perfectly valid approach to doing this. Okay, and one other thing I wanted to mention, if you're actually using Dapper in production in your application, you can, the basic Couchbase SDK is very, very similar to the way Dapper works. It's, this first example here, this is a Dapper, a piece of code that uses Dapper. So we're just querying, putting in the SQL, putting in some parameters. The second example is the same thing with Couchbase SDK. It's not exactly the same syntax, right? There's a $ instead of an @ and there's this options object instead of just an anonymous object for parameters. But you can see that it's very similar and very comfortable. I actually thought about making a Dapper extension somehow for Couchbase. I think that would be a fun thing to tackle someday. I'm not exactly sure how I'd make it work. I'd have to do some sort of Couchbase implementation of IDB connection, maybe. I don't know. Let's think about that. But that might be a fun thing to do. All right. How are we doing on time? We doing okay on time? Do a quick demo here. Is that all right? All right. Where are we going to start here? Let's see. Let's bring up my, this is Visual Studio here. And I want to show you, this is all available on GitHub, by the way. I'm going to show you just a sample console app that I created that uses this library I've created. And this is the configuration, the basic configuration you need. So here's the connection string for SQL. Here's the connection information for Couchbase. Some other settings, those extra long table names I was talking about, various flags you want to set for this utility. And I've got over here on Data Grip, here is my local SQL Server database, AdventureWorks. You can see all the schemas there, human resources, person, production, purchasing, sales. And I can expand those and see all the tables in them, which, again, I just love how cool this is. I can just quickly focus on one schema at a time. I love it. I love Data Grip. I also love Data Grip because it can connect to Couchbase too, which is very cool. Okay, so I've got that SQL Server there. Now over here in Couchbase, I've got a Couchbase server running locally here, just a cluster of size 1, which is fine for development. In production, you typically have a whole list of servers here that make up your cluster. But either way, for a developer, it's basically the same experience. I've got a bucket here called AdventureWorks JetBrains. There is nothing in it. The only scope and collection is default and default. This is kind of like the DBO in Couchbase speak. So it's just nothing there to begin with. So let's go ahead and run this program. Fingers crossed that this works. A lot of logging stuff being written to screen here, but we're copying over all the structure and data from SQL Server AdventureWorks into Couchbase. So that's the collections and the users and the scopes. Now it's copying over the indexes. As I said, this is a place where we definitely use some improvement. But it's going to just take a sample of indexes. There are 100 and some indexes in AdventureWorks. We're only going to copy over 5 for the sake of a demo, and then it'll start copying over the data. So let's just go over here and look while it's doing that. We can see we've now got all 5 of those schemas converted into scopes along with default. And we've got inside a person, we've got all these different collections in there as well. And it's going to start copying data over. It's probably doing that right now, right? Yep, copying data over right now. So it's going to take a minute or 2 to do that. But what I've also done is, just by that conversion, we're just converting the data itself over. We still have to think about how we're going to access that data. So what I've done is I've created in the same GitHub repository, I've got 2 sample projects over here that are both using Web API. One uses SQL Server and one uses Couchbase. So I'm going to go look over here at SQL Server and person controller. And so person controller, this is just a handful of endpoints to show off, basic ways we'd interact with SQL Server. So I'm using Entity Framework for most of this, but Dapper would be fine too. It's just the same general principle here. So this endpoint gets a list of all the persons, but it gets it in paged. So I want, say, page 0, page 1, page 2, etc. So it's going to use the Entity Framework here on this person's entity to order them by last name and do a skip take to do a page. I just want the ID, first and last name, and then put that to a list. All right, easy enough. And I also want to show over here the Couchbase version of that. This is just kind of a handy way to, again, kind of a translation, like a phrase book, to see how would I do that same thing in Couchbase. So here's the get persons page async. Now, Couchbase doesn't have Entity Framework provider, at least not yet. So I'm just going to use some raw SQL here. There is a library called link to Couchbase. So if you want to use link, you can use that here instead. But it's not Entity Framework provider. It's just a link provider for now. But here's the SQL. It's very similar to what you'd see generated by Entity Framework. Just a select and a from, and we've got a limit offset for paging, order by last name. It's all happening there. And again, to the list async. Okay, so I think we're probably done at this point. So the data is over. So we'll go ahead and let's just run the SQL Server example real quick here. Start new instance, open this in the browser. Hopefully, okay. And I've just got Swagger built in here so we can navigate the endpoints. So here's the endpoint I talked about. So let's start with page 0. Why not execute that? And what's happening here? Value cannot be null. What? What are we doing? Did I break something already? I just tried this before, I swear. I swear I did. Default connection. That's right, isn't it? Default connection, AdventureWorks. What did I do? Oh gosh. Let me see. Try this again. I don't know what's going on here. Debug, start new instance. I do have SQL Server running, right? I'm pretty sure I do. Oh, I know it. No, this should work. SQL Server, startup, yeah. Page number 0. And I'm getting it, value cannot be no connection string. Why isn't it giving me a connection string here? There's a question about stored procedures. I see your question. I will definitely get to that here. I'm going to spend just a few more seconds trying to figure out why this isn't working. AdventureWorks context, default connection. JSON, database AdventureWorks. It's localhost, right? Yeah, there it is. I saw it here in DataGrip too. That's frustrating. Okay. Always with the demos, I swear. All right. Sorry to debugging live here, everybody. But this is the kind of thing that, like I said, reality is always messier than marketing makes it out to be. Why isn't this connecting to SQL Server? If anyone sees the issue, shout it out. Startup. I swear I did this. This configuration being loaded, LOL IIS reset. Oh, that might be a good idea. Except I'm not using IIS. I'm using just .NET there. I'm pretty sure. Configuration, I don't see why it wouldn't be loaded. Startup. Why wouldn't it be loaded? This is probably the sort of thing where I was messing with it and I accidentally copied and pasted something. I don't know. Just set a breakpoint here and see what happens. Okay, so configuration, get connection string, default connection. What does that do? Media window. I can't type. There we go. It's not getting the app settings JSON file. Why isn't it getting that? So it's not loading. App settings on development. No, I don't think so. And like I said, this was working earlier when I was practicing and trying this out. Oh, is this some weird JSON something? Here, let me just do a quick check of see if I made a typo somewhere. You see any problems with this JSON? That might cause it to not load. Copy paste connection string just for this demo. All right. That's good thinking. Ah. Okay, and use SQL Server and another one. Okay. All right, we'll try it again. This doesn't work. We're going to move on. It's just remove the UTF BOM. I don't know what BOM is. It's another one of those acronyms. Okay, we'll try it here. Come on, fingers crossed. Page 0 and... Okay, well, it's working. I don't know what the heck happened there, but I must have screwed something up when I was practicing. But there you go. There's the results. There's one page of persons. So again, Saeed and Catherine and Kim, all there. I don't know why Kim's in there twice. That's curious. But anyway, that's the results we're looking for. I could go ahead and then take one of these IDs and drill into a specific person, another endpoint, and try it out, and I'll get Saeed there. Right order mark. Okay, I'll look into that. Thank you very much for those. But I think we'll power on through the demo here. And so then I've got the Couchbase version of it, which I'll go ahead and run that. Now this won't return exactly the same data necessarily because I only copied a sample of the data over. I made a cleanup before. It's very possible I did that. So it's not going to return exactly the same data, but it'll be a similar like sample of the data. Because I don't want you to sit here for 30 minutes watching data get copied over. So here's the Couchbase version, entering the same page number 0. And I even made a note to myself about this, and I didn't do it. So there are some indexes. Again, because I didn't want to copy all the indexes over, I made a copy of these indexes that I should have. So I'll just go ahead and do this real quick here. AdventureWorks 2016, it's AdventureWorks JetBrains. This is really exciting, I'm sure, watching indexes getting created. Okay, there we go. Now we'll try it. This is the ASP.NET version using Couchbase. Bug, start new instance. So this would have worked just fine if I let it sit and run all the indexes. Like I said earlier, it's only running 5 of them because we only have so much time today. So I'm just creating one manually. All right, there we go. Same sort of results. Oh gosh. So here, remember the pipelines I was talking about? It's actually working here. So I'm mangling the data as I copied it over. I forgot to take that part out apparently too. I wonder if I accidentally just jumped to a fork or something. And that's why all these problems are happening, right? So if we go back to my program here, yeah. So I've got this example pipeline that scrambles sensitive data, and it happens to be the first name and last name of person. So that's why it's all scrambled looking over here. Normally this would say, you know, Saeed or whatever it was, the correct names. So this demo didn't go so great, but get the general idea there. All right. So that's what I wanted to show, and you can dive into all this code's out there in the GitHub repo. So let's hop back over to the slides, and a few more things I want to cover. And then you can send your questions in. So what can't be automated, at least not yet? So there's a question about Sprox in there. Also, you know, it's kind of implied, what about views? What about triggers? What about functions? So there are some equivalents to these things in NoSQL databases like Couchbase. Typically, Couchbase or other NoSQL databases has something called views or map-reduce views or something along those lines. That's the closest analog to a SQL Server view, like a materialized view. Those things are a little less flexible because they're typically written using JavaScript and not a language like SQL that it can do joins and things like that. So, but it's the closest analog. Those are kind of on their way out, MapReduce views, because of, you know, some of the performance implications of it, scaling implications, and just the limitations in what you can actually do with the MapReduce functions. Couchbase has something called UDFs, user-defined functions. So that's a direct analog to a SQL Server user-defined function. And you can also use that if you have a stored procedure that's like a read-only select stored procedure. That would be a good substitute for that. Functions as well, user-defined functions, I mentioned that. There is a service called Couchbase Eventing, which is a close analog to triggers, not exactly the same thing, but that allows you to write some business logic into your database if you want to keep it close to the data. Those can respond to mutation events like create, update, delete. And so those can be used in lieu of Sprox or triggers in some situations. I will say that among developers who interact with SQL Server, it's been my experience, this is back to the Darmok and Jalad, that stored procedures and Sprox and triggers can be very controversial. There's a spectrum out there of never ever use them. And there's people out there who are like, you got to use Sprox for every single time you interact with a database, right? So depending on who you're talking to, the lack of Sprox here, this may be a good thing for you. I don't know. Depends on where you fall in that spectrum. The other thing I'd mention on the migrating queries over, there is again there's no foreign key or unique constraints. You can have something like a foreign key to represent joins and relationships, but there's no constraint for it. There are some workarounds and alternatives, and one of the things that NoSQL has been adding recently that you may not be aware of is ACID transactions. So you can actually have a transaction that modifies multiple documents. And the other thing I want to mention here is that with SQL Server, the only way to interact with SQL Server is through SQL. Whereas with a NoSQL database like Couchbase, you can actually do a key value lookup, which I kind of skipped this over in the demo because we're having some problems there. But if we're just selecting, say, one piece of data at a time, one row of data at a time, or one entity at a time, we might want to switch that to use the key value API instead of involving a SQL Server parser, indexer, and engine. So that is something else you should consider. That might give you better performance in the long run, is to use that. Should I automate? Should I go through this process? And if you're interested in going to NoSQL because of some of the benefits, this is kind of the decision you have to make. And this is why a tool like this is going to be helpful for you to get a head start when you're doing a proof of concept or evaluation. Is the traditional approach has been just rewrite everything. Just throw out the database that you had before and rewrite your application, and throw out the application with it and rewrite your application to use a new database. And that is going to be a really high effort project, a really high risk project, and probably expensive, but it will give you the most benefits out of the new database, is rewriting it from the ground up. But I think, and this is something that Couchbase has been leaning towards, is, that's all well and good. We're happy to do those and help you with those. But there's also a class out there of developers and applications and use cases where let's just start with low effort and low risk, and we'll just do, like I said, a lift and shift of the data from your relational database into Couchbase. Just host it with as few as changes as we can get away with, and see if that's going to give us the performance benefits, the flexibility benefits, scaling benefits that we want. And then we can start to optimize that. And we can start to combine those different tables into one entity. So in my example, I have, in AdventureWorks, you have a person table and you have an email addresses table. And they're separate, right? Because I can have more than one email address. I may want to consolidate those and just have email addresses be an array inside of my person documents. And that's going to save us some joins. It's going to save us ACID transactions and that kind of thing. So we can optimize that as we need to and refactor as we need to hit our performance goals. And we can keep going up that chain. So these are all valid approaches. It really just depends on what your goals are, how much time do you have, how much effort do you want to put into this, how much risk do you want to take, that sort of thing. I will say that those sample applications that I was just struggling with, I actually decided to do some load testing on them, because I wanted to see, after I converted from SQL Server to Couchbase, I wanted to do a sanity test. So this is like a back of the envelope sanity checking load test. It's not a rigorous benchmark. Don't take this as gospel. This is the performance difference. So I ran some load testing on both of them. It looks like it's about 250 clients over a minute, roughly speaking. And this is the SQL Server load test, so ASP.NET plus SQL Server. And I'm just testing the endpoint that uses paging. So just getting one page from the person table in this case. And there we go. So average response, 76 milliseconds. That's pretty good. That's pretty good. I ran the same test on Couchbase. Again, same endpoint. And this is the level 5 conversion. So I didn't do anything with the data modeling changes. I just copied the data over directly, as I showed you in the slides here. And going up to level 4 takes some more human thought and work. But just for the sake of evaluating this and sanity checking this, let's put it through a load test. So same load test here, 250 clients over 1 minute. Average response time about the same, 70 milliseconds. Slightly better, but about the same. So this is a test that's being run on my local machine. It's, it may not reflect reality that well, but it is at least a sanity check. So this is kind of the at worst. We have the same performance, the same latency, but we've gained all those other things, scalability and high availability and flexibility. I would expect this load test, as we have more clients, for Couchbase, a production level Couchbase cluster to do better than SQL Server. I would expect that to happen. So we've gained those things when we're actually going up to scale and going into production. All right, so let's wrap up here and make sure to throw those questions in there, and I will answer them as I see them. Just to wrap up, though, I think NoSQL is becoming a better fit for more and more use cases. We can stop throwing all those shapes into the same square box of relational and start looking at NoSQL to answer some of those use cases, while retaining those core benefits that I keep harping about: scalability, high availability, and performance. My approach to conversion is not a novel one, as I have come to learn. There's another project out there called Couchgress, which aims to do almost the identical thing, going from Postgres to Couchbase. So scopes and collections mapping to Postgres tables and schemas. And there's another effort actually by someone else at Couchbase, unbeknownst to me, was doing the same approach with MySQL. He was creating his scripts in Python there. So if you're interested in those efforts, check out those there. There's some links there for you. One other effort I want to mention, and this is from a company called Molo17. I believe they're based in Italy. They make a tool called GlueSync, and this is a production-grade commercial tool that can actually do a live synchronization between Couchbase and SQL Server and vice versa, and also Oracle for that matter. So this is like a production, unlike my sort of experiment. This is a production level commercial solution that can help you do this. And they've got a bunch of customers that are doing this very thing to kind of take advantage of legacy SQL Server and some of the cool stuff they can do with Couchbase, and without ditching one or the other. If you want to try out this tool, if you have ideas for it, if you have criticisms, or hey, have you tried this, or any sort of questions or feedback, I love that stuff. Go ahead and submit an issue, even if it's just suggestion or feedback, and you're just dropping it off and leaving, and don't ever plan to come back in a while. I really would like real world feedback and ideas to improve this project, this experiment. And of course, pull requests are welcome too, if you're interested in doing that sort of thing. If you have anything else you want to talk about with Couchbase, any questions or problems or comments, you can email me. There's matthew.groves@Couchbase, twitter.com/mgroves. You can find me on LinkedIn as well. This is the cartoon that more represents what I'm looking like post-2020, kind of grizzled and sort of like a world weary, I guess, not smiling as big. But that's it. That's the application. If you have any other questions, throw them in the chat there. I'm happy to discuss it further with you. I do want to say thank you to all the JetBrains staff for having me here at .NET Days. I really appreciate it.
Yeah, we were really happy to have you. I mean, that was a really cool talk. I know when folks start to go from a relational database to NoSQL, the thing that catches people up the most is probably document modeling. Do you have any tips for people out there? You talked about going from level 5 to level 4 migrations. Yeah. What tips do you have for folks starting out?
Yeah, I mean, I've actually just finished a presentation on this recently, because you're absolutely right. JSON data modeling is something that's very crucial. And so going from level 5 to level 4 is where you start to think about your entities. So as I mentioned, the person and email address, those are two different tables in relational. Does it make sense to combine those into one entity? Because with JSON, you can now have more complex nested structures, sub-documents, arrays of documents, etc. So you basically you think of an entity diagram, like entity framework type of diagram, and start looking at that and drawing boxes and say, well, what if I draw a box around these 3 tables? If you're familiar with domain-driven design, the Blue Book, the idea of aggregate root might be a place you can go and start thinking about, what are my aggregate roots? And maybe those should be the document models. And in fact, I think a long time ago, Martin Fowler, when he was first talking about NoSQL, he liked the name aggregate-oriented database better than document database. And I agree with him, but it hasn't really caught on as a name.
Yeah, it's a bit of a tongue twister, so I can see why people went to document database or NoSQL database. Aggregate object database might be difficult. especially in meetings with your team members. So, Rachel, do you have any questions? Matthew's been pretty good about answering questions.
Yeah, I didn't see any that he didn't really get to answer. But I got to say, .NET folks, I'm glad he's out doing this talk because especially the part in the beginning with that little quick table of, if you had this in an RDBMS, here's the rough equivalent in your document database, because it's more about shifting your mindset to think about working with data in a different way, and that way is not relational. And as we know, sometimes you can get set in a mindset and then you are trying to fit that square peg in the round hole, and then you're crying like that girl in the video, right? This happens every time, and I see it time and time again, going from one paradigm of programming to another, right? Like OOP to functional even, or, RDBMS to document, and all of these things. So it's really good that we have these tools and folks out there creating content to help with those shifts in your thinking.
Actually a good question just came in. Is it okay to duplicate your data? Because I know that's from Rachel talking about paradigm shifts. Duplicated data in SQL is normally a no-no. But what is it like in a NoSQL database? Yeah, so it's actually kind of interesting. A year or two back, I went and read E.F. Codd's original white paper on the invention of relational databases. I highly, that's a humble brag, I guess. But anyway, he invented relational databases as we know them today. And one of his comments in there was, I'm going to paraphrase here. Basically, I'm optimizing for disk space because it's so expensive right now in the 1970s. But he saw a future where, if disk space wasn't so expensive and performance is more important, duplicating data would be totally fine. So even way back then, he foresaw that could be the case. Now, I will say, there are some NoSQL databases where duplicating data is necessary. If you're doing a wide column type of database, Cassandra type of database, you kind of have to do that because there's no indexing, there's no joining. A document database like this that has a join feature and has ACID transactions, that's less of a problem unless, again, it's going to help you meet your performance requirements, right? So you can still have your data be somewhat normalized in a database like Couchbase if that's what you want. But if performance is a premium, then you might want to start thinking about, all right, how do we copy this data over and keep it in sync so that we can improve performance and keep our data, data integrity. Yeah, I mean, I think you pointed out in your talk, definitely with Couchbase, just having SQL-like syntax for queries makes that leap just so much easier. And while you should make a paradigm, mental paradigm shift, the syntax really lends itself to kind of ease into that shift rather than jumping out of a plane with no parachute, right? So it's pretty cool stuff. The other thing I wanted to ask, you didn't really hint at it, but what features does Couchbase have that maybe SQL Server doesn't have or maybe doesn't do as well?
Yeah, so some of the things about Couchbase that I didn't really cover, because this session was all about how do I put my relational data in NoSQL, right? But Couchbase has some features in it that kind of lend themselves to other types of applications. So, for instance, we have a full mobile stack. So the last speaker was talking about a case where you might want to cache your data locally in local storage or whatever. Couchbase, there's a Couchbase Lite, which is a database you can deploy to your Android, your iOS, even your Java desktop apps that can give you an offline database experience. So you can read and write to that data. If you don't have any connection, let's say you're out at the curb, just out of the range of your restaurant's Wi-Fi, and you're fulfilling a pickup order or something, you can still read and write to your database locally on your portable device. And when you get back into the building, it's going to sync up automatically to your data. So that's a great one that Couchbase has, and that's actually what a lot of people using GlueSync are doing. They're using that to sync data from mobile devices to Couchbase to SQL Server, and to integrate with the rest of their ecosystem. Couchbase has a full text search engine built in. So that's really nice to, for things like catalog searching and even geospatial searching. If I want to identify a polygon and find all the restaurants within that polygon on a map, I can go and do that with Couchbase. Analytics is built into Couchbase as well. So if you're concerned about reporting in NoSQL, I have a whole other session on that. If you're concerned, well, this NoSQL stuff's great, but what about all my reports and my BI? Well, there's a feature there for that too. Yeah, I could talk about it all day, but those are some of the big ones, I guess, that Couchbase offers.
Yeah. Well, I don't really necessarily see any more questions. Matthew, thank you so much for this talk. I think it was an awesome talk. Don't worry, the demo gods always get somebody. I didn't think it was that big a deal. It was a great talk regardless. So thank you again for your time. Thank you, Couchbase, for lending us Matthew for the day. Thank you, and we'll see you later.
Thanks, everyone.
Thanks.
Yep.